Hello, welcome to this lesson on Unitary Matrix. So this is another special classes of matrices. So what is a unitary matrix? So we say that it is a unitary matrix, again, if the complex matrix satisfy this. So we have A raised to H is equal to the inverse of A. Or if you still recall our discussion in Hermitian, A raised to H means that this is both the conjugate and the transpose. So after getting the conjugate of the matrix, you have also to get the transpose of a matrix to come up with A raised to H. For other books, so let us consider using our whiteboard. So other books use the notation asterisk, which also means A raised to H. So this is, of course, a unitary if the result is equal to the inverse of the matrix. So we call it as unitary matrix. However, we are not yet, of course, done with our discussion with inverse matrix, but just to have an overview of what is inverse matrix, when we are, so let us consider clearing our board. When we are coming up now with inverse operations, like for example, in real numbers, for us to come up with a result that will be equal to identity 1, so you have to get for the reciprocal. So 5 times 1/5, or if it is, for instance, 2/3, so you have to multiply this to 3/2 to get 1. So these are the reciprocals, but this is for real numbers. Now, how about in the, or rather this is for constant numbers. How about for matrix or matrices? So we also have, as mentioned in the properties, identity matrix, and also we have the uh, inverse matrix. So here, if we have matrix A and multiply it now to our inverse matrix, the result is equal to the identity. So let us erase this. So the identity is identity matrix I. So what is this identity matrix? So this is presented in our discussion of the different types of matrices. So we have, of course, 1, 0, 0, 1. So this is in order 2. So if we expand it, so the diagonal is equal to 1, while all other values, upper and lower, the diagonals will be equal to 0. So that's for the identity matrix. Now, if we are going to consider or going to determine whether our matrix is a unitary matrix, given that if our A sub H is equal to its inverse, then it means that it is unitary. So for us to determine that, of course, we have first to get the conjugate and then get the transpose of that conjugate, and then finally multiply it to A, and if the result is the identity, then it means that it is a unitary matrix. Because of course of this, obviously A multiplied by the inverse is equal to the identity. So if we multiply the transposed, or rather the a raised to h to our a, and the result is the identity, then it means that is the inverse. Or not unless you are already familiar in computing for the inverse or to obtain the value of the inverse matrix, then it is also okay to get that and then multiply. And if the result is the identity, then it means that it is the unitary. Okay, let us do that. So first, so as mentioned, our AH is actually equal to, we have to get the conjugate and then get its transpose. Transpose of the conjugate. It is conjugate plus the transpose. Okay, so here we are going to, and then for our, for us to determine if this is the identity or if it will result to its inverse, if we are going to multiply this now to our A, if this is the inverse, then it must be equal to the identity. So this is what we are going to do. Again, if this is equal to the inverse, then the result must be the identity. Okay, so let us do it now. So let's consider this example. So let's have A is equal to I square negative 3 halves negative, square root of 3 halves and I square. So we have the following elements. I square is square root of 3 over 2 is square root of 3 over 2 and I over 2. So first, we are going to get its conjugate. So the conjugate is negative I over 2. So we have here retain 3. Let us square root of 3 over 2. And then we did not do anything with our square root of 3 over 2. But the conjugate, of course, of I square is negative I over 2. So the conjugate of I over 2 is negative I over 2. So if you still recall our discussion in the Hermitian, so as mentioned, we just change the operation of our I. But for this case, that is for the addition or subtraction, or in other words, we are referring to the signs. So it does not mean here that since we have I over 2, it will become multiplied by 2 because that's the inverse operation. So what I meant is that we are going to change the operation, and we know very well that I over 2 is the same with 0 plus I over 2. So the plus sign now will be changed into minus sign or negative sign. Okay, so let us move to the next one. So we have the conjugate, and then now let us get the transpose. So the transpose of this is equal to, so we will just interchange the position of the row and the columns. So negative I over 2, negative 3 halves, next column, next row, I mean, square root of 3 halves and negative I over 2. Negative I over 2. Now, let's take note of this value. So this will be multiplied here. So what we are going to do in the next slide or in the next page of our board is to multiply A multiplied this result. So it is the A H and find out if it is equal to I for the identity. Okay, so let us do that. Let us clear some parts of our board, or let us just rewrite it. So again, the given value, so the given value is A multiplied by A. So we are going to find out if it is equal to I. And the A is I square, I over 2 square root of 3 halves, the square root of 3 halves, and I over 2. Okay, this is our A. And then, the computed value of our A sub H is negative I square, and then square root of 3 halves, square root of 3 halves, and I negative I square. So this or the values or the elements of our matrix. So multiply, we will do the dot product. So this is equal to, so we know that it will be first column to the first row to first column. So this one, first row to first column. So I2 multiplied by negative I2, and then plus 3 square root of 3 halves multiplied by square root of 3 halves is 3/4. So we have actually I squared over 4. So let us change this, or let us change it later. Okay, next. I squared or multiplied by, so now we will also consider this row. I squared multiplied by 3 halves, and then plus I squared multiplied by square root of 3 halves rather. Oops. Let us rewrite it. So as mentioned, we are computing for I over 2 square root of 3 halves, square root of 3 halves, and I over 2. And our A sub H is negative I square, and then square root of 3 halves, square root of 3 halves, and negative I square. So in our first computation, we obtain, as mentioned, I squared multiplied by a negative I squared is I multiplied by a negative I is a negative I squared. And we know that I squared is negative 1. So which means a negative of a negative 1 is positive 1. So it is 1. Okay, moving to the next one. We have I squared 1 over 4, and then square root of 3 over 4 is equal to square root of 3 multiplied by square root of 3 is 3/4. So we have 1/4 plus 3/4. So next, so we have square root of 3i over 4 minus square root of 3i over 4. Okay, next, let us consider this part. So negative 3 halves multiplied by negative 3 halves is equal to 3. 2 times 2 is 4. Square root of 3 multiplied by square root of 3 is 3. Plus negative I multiplied by a positive I. So again, that is negative I squared. Negative of I squared is positive 1. So 2 times 2 is equal to 4. Okay, next. Let us see. So where are we now? So this is actually here. So 3/4 plus 1/4. I misplaced it. Okay, let's go back. So here we have negative this part with our first value here. So negative 3i over 4 and then negative 3i over 4 plus I square multiplied by negative 3 squared is also positive 3i over 4. So these are the values. So 1/4 plus 3/4 is 1 because of course 4 over 4 is 1. And the square root of 3i over 4 minus the square root of 3i over 4 is 0. And then the next one, negative square root of 3i over 4 plus the square root of 3i over 4 is also 0. And 3/4 plus 1/4 is equal to 1. And this is the identity. Therefore, matrix A is unitary. Okay, so let's consider another item. How about if we have the following values for our matrices? So A is 1, I, I, my negative 1. So again, it is 1, I, negative 1. So to get a conjugate of matrix A, so this is again 1, negative I, negative 1. Get its transpose. So it is equal to, let's transpose 1, negative I, and negative 1. So again, 1, negative I, negative 1. So multiply this value to our A because this represents, oops, let us go back to our board. Because it represents our A raised to H. Okay, let's do the multiplication. 1, I, negative 1 multiplied by 1, negative I, negative 1. Okay. So 1 times 1, so the usual method, the dot product, 1 times 1 is 1, I minus I multiplied by I is negative I squared, so plus 1. Okay, so next, 1 times negative I is negative I times negative 1 is negative I. So negative I minus I. So let us go back so that it will be clearer. Let's repeat. So 1 times 1 is 1. 1 times 1 is 1 times negative, this is negative I. 1 times negative I is negative I plus a negative I. Followed by I times 1 is I plus negative positive I. Followed by negative I times negative I is negative I squared plus, that's plus, and then negative 1 multiplied by negative 1, that is again plus. So which means this is equal to 2 negative 2i 2i2, which is not equal to I. Therefore, A is not unitary. Okay, so that is how to compute or to determine whether it is unitary or not. But later, if you already know how to get the inverse of the matrix, then you can also, instead of multiplying the a raised to h to our a, or a times a raised to h rather, so you can also get the inverse of the matrix and determine now if the result is the same with your result of a raised to h. Okay, thank you for watching.